it says, what is the acceleration from gravity on a planet where an object falls from rest 17 meters in 3 seconds? All right, so we want to know the acceleration on a planet where an object falls from rest 17 meters in 3 seconds. So, as always, step one is to figure out the givens that the problem tells us. What information do we have here?
You got time, 3 seconds.
Yeah, great. Time is 3 seconds. Good. What's another one?
Initial velocity.
Right. Is what?
17 meters.
Is 17 meters the initial velocity? A meter is not a velocity, right? A meter is how fast.
Wait, then it would be 0? No.
Initial velocity is 0. That's right, because it's falling from rest. So that means it's not moving yet, right when we let it go. So that's our second given, is Vxi is 0, or really Vyi. And then we do have, so 17 meters is in there. What quantity is the 17 meters?
Displacement.
Displacement, right? That's how far it falls. I'm going to give that a delta y because we're talking about vertical displacement. And I usually forget until later, but since we're falling downwards, right? We're falling from a higher point to a lower point. What should I do to that displacement to indicate that? Right, and how do I make sure that I know the direction is a downwards direction? And it's not exactly right to say delta y is 17 meters, right? Because we're moving downwards.
Negative.
Negative, right? Our delta y is negative here because we're falling in the downwards direction, and the downwards displacement is going to be negative. Okay with that so far? Anybody? Questions about what we've done to this point? The unknown that we're looking for, what quantity are we looking for here? Anybody? It asks it pretty specifically.
What'd you say, mister?
What's the unknown that we're looking for? What are they asking for?
What's the acceleration?
Yeah.
Yeah, acceleration.
So what, right, acceleration. So I'll use AY, and that's my question mark. That's my unknown. Okay, so I have delta T, I have VYI, delta Y, and AY. So which of my kinematics equations would I pick? The one that has those 4 symbols?
The first one.
First one.
Wait, no.
Yeah, not the first one, right? Because that's got a VXF, and we don't have that at all.
The second one.
There you go. Second one sounds good, Zeke. So I'll copy that down. I've got my final velocity equals my initial velocity plus acceleration times time. Wait a minute.
I think it's the third one.
Yeah, but this isn't the right equation either, right? This one doesn't have the displacement in it, right? But we need the displacement. And this one also has VYF, and we don't have that. So not the second one. That's okay. That's right. Jose's right. It's the third one, right? The third one's the only one that has our displacement, our time, our acceleration, and the initial velocity. So that's okay. Delta Y equals Vy initial times time plus 1/2 the acceleration times time squared. All right, so now we've got to do the rearranging, right? We need this acceleration by itself. This is going to be much easier to rearrange if we remember that when Vyi is 0, right? So over here on this side, if Vyi is 0, Vyi times time, whatever time is still going to be 0. 0 times anything is 0. So if we get rid of that whole piece, it becomes much easier to rearrange. We don't have to do any quadratic equations. So now we just have delta y is 1/2 acceleration times time squared. If I want this acceleration by itself, right, that's my unknown. What do I need to do to get acceleration by itself here?
Divide.
Yeah, what do I divide?
Think everything or
Just about everything, right? But if I divide everything, then I won't have the acceleration on this side anymore. Right? I want to divide,
yes.
divide by everything except for acceleration, right? So if I divide by 1/2 and by delta t squared, the 1/2s cancel, the delta t squareds cancel, and I only have acceleration on this side, and that's what I want. Of course, whatever you do to one side, you have to do to the other side. And instead of dividing by 1/2, I will multiply by 2, which is the same thing. So our final equation for today then would be acceleration is 2 times displacement over the time squared. Okay. So I can go ahead and plug my numbers in now. I've got 2 times negative 17 meters divided by my time, which is 3 seconds, and all that's squared. So I can already tell I'm going to get a negative acceleration, and that's okay because on any planet, the gravitational pull is downward, so I would expect a negative acceleration. So 2 times negative 17 divided by 3 squared gives me negative 3.77. Really negative 3.78 if I round up. And for the unit, I've got a meter on top and seconds squared on the bottom. So that's meters per second squared, which is good because I'm looking for an acceleration, and that's the SI unit for acceleration. And negative 3.78, well, that's less than here on Earth, right? On Earth, we know the acceleration from gravity is negative 9.8 meters per second squared. This one's somewhat smaller. So on this planet, if you let something go, it's going to fall slower than here on Earth. Okay, anybody questions or comments on that? Need anything clarified or anything at all?
No.
All right. Well, thank you very much for coming today, and we'll finish chapter 20 tomorrow and go over the next problem of the day then.
All right, bye, mister.
All right, have a great week. I'll see everybody tomorrow.
Sir, I have a question.
Oh yeah, go ahead.
Do we need to join the meeting every day, or just like can we just do like the work in our own?
If you're, you should be coming to the classes, you should be coming to the meeting every day. If you're doing all of them and getting them all right, that's probably going to be fine.
Okay.
And I do have, try to come as much as you can. If you miss days here and there, that's okay. And I do post the video part of I post a video for the problem of the day part. So if you do miss one and you need to look at and see if you did the problem of the day right, that's on YouTube.
Okay. Thank you.
Yeah, no problem. Any other questions? Anybody else?
Wait, so what if you get them wrong and you still come to class?
If you're coming to class every day and you're reading and asking and volunteering some answers and you're still getting the problem of the days wrong, that's okay. You're still going to get credit if you're coming to class every day.
All right, thanks.
All right. Do your best on them, of course. Okay, so have a great Monday, and I'll see you all tomorrow morning.
You too.
Bye bye.
Bye, mister.
Bye.
Bye, mister.